Okay, we will start. So once again, very good afternoon all. So today we are having this particular lecture based on the virtual lab on the mechanics of material, or it is also called as a strength of material. As already we have discussed in our advanced technical training, the concept of mechanics of material or the strength of material, both are correlated with each other. So, and the standard name for this particular subject is strength of the material. So now today we will take some of the practicals or the virtual lab on the mechanics of material, or it is also called as a strength of material. Okay, so if you go through this particular syllabus, or if you go through your university syllabus, so total 8 chapters are there, and that particular 8 chapters are related to your theoretical calculation. So that means some standard concepts are there, definitions are there, then list of the formulas are there, and then you have to use that particular list of the formulas for the solution of the problems. Okay, but if you go through that particular syllabus, there was only assignments. That means assignment on chapter 1, 2, 3, 4, like that. But there is no any experimentation part, or there is no any practical to this particular subject, that is mechanics of material or the strength of material. But this particular subject is also very important in order to check the strength of the material. The name itself suggests that strength of material. What it indicates, strength of material means, so whatever the number of forces or whatever the number of loads we are applying on any type of body, at that time what happen, that body will sustain that amount of applied load. That means there is a resistance to the deformation. If load is applied, deformation is taking place, no problem. But that body or that particular material will sustain some amount of load with some amount of deformation or without any deformation, then we can say that the strength of that particular material is very high. Means we are checking their strength, but in our regular syllabus or in our regular subject, what we have calculated, we are having the standard formula delta L is equal to PL upon E. So we are using the P value, we are using the EL value, then cross-sectional area and Young's modulus E. And we are putting all this particular given data in the formula, and we are calculating the deformation theoretically. For example, deformation is equal to 0.05 mm. It may be tension, it may be compression. So this is the theoretical method, or this is the analytical method. But if practically I have to check that deformation, whether it is 0.05 mm or whether it is mm, 1 mm, like that, if we have to go for the experimentation, at that time, such types of the virtual labs, it plays very important role, in which how the actual experimentation will be conducted in order to check the strength of the material. In addition to that, in this particular virtual lab, we are going to check the properties of the material. Properties means the material is having the tensile strength, compressive strength, bending strength. So these are the number of strength that material is having, and in order to check that particular strength, this particular experimentation will be carried out. So if you go through this particular website, so this is one website of the virtual lab which is developed by the IIT Kharagpur. So here the number of tabs they have given. If you look at to the first, so this is the subject related to the strength of the material, and the basic introduction they have given related to the strength of material. That means why this particular subject is important. Then in order to check the strength of the material, or in order to check the properties of the material, which types of the experiments are to be carried out, and what is the basic procedure in order to check the strength of material. That's some introductory part they have given here. Now, if you look at to the second tab, here they have mentioned list of experiment. If I will click here, so this is the list of experiment in front of you. So this is the list of the experiments. So if you see here, that is ISOD impact test, Charpy impact test, direct shear test on mild steel, direct shear stress on the timber specimen, direct shear stress on the mild steel plate, then Brinell hardness test, bending test on the mild steel, Rockwell hardness test, Vickers hardness test, tensile test on mild steel, tensile test on cast iron, compressive test on mild steel, compressive test on cast iron, and torsion test of the mild steel. So this is the list of the experiment which is to be performed under the strength of material or the mechanics of material. So in the previous syllabus of this particular strength of the material, this all the tests will be considered under the strength of material. But now, as per the modified syllabus, out of this particular total number of tests, some tests they have considered under the test of under the strength of material, and some of the tests it will be considered in one of the subject, which is in third year, that subject is called as a metallurgy. So in the third year, you are having one metallurgy subject, and under that particular metallurgy subject, some tests will be considered from this particular list. But now, as per this particular modified syllabus, if you look at to our regular syllabus of the mechanics of material, in that, if you look at the first chapter, that is simple stress and strain. In that simple stress and strain, there is one theoretical point is there. Yes.
Sir, voice is breaking, sir, more.
Okay, just wait. Now it is audible. Please check.
Yes, sir.
Okay. So if you go through our regular syllabus, maybe our mechanics of material, and if you look at to the chapter number 1, that is simple stress and strain, and in that particular chapter 1, theoretical point is there, which is called as a stress strain diagram for the ductile material and the stress strain diagram for the brittle material. Okay, so whatever that particular diagram they have represented in the ductile material, maybe proportional limit point is there, elastic limit is there, upper yield point is there, lower yield point is there, then ultimate stress point is there, and last breaking stress or breaking point is there. So this graph, it is not drawn by the rough understanding. So initially, some of the experiments they have performed on any type of material or whatever the material we have selected, for example, mild steel. So initially, they have performed some experiments on the mild steel, and whatever the results they have obtained from the experimental concept or experimental study, that result they have represented in the form of stress strain diagram for the ductile material or the mild steel. Similarly, we are having the second graph, that is stress strain diagram for the brittle material, for example, glass. So in that, again, only 2 points are there. One is proportional limit and then fracture. So this is not, that particular graph is not drawn by some imagination. So initially, they have conducted some experiments on the glass material, and whatever results they got from the experimentation, by taking the reference of that, they have represented that particular graph, and then that particular graph is implemented in your syllabus for your understanding purpose. So if you look at to this particular syllabus of our mechanics of material, in that basic chapters are related to the, for example, simple stress and strain. Then one more chapter is related to the torsion. So in torsion, what we are doing, we are not calculating the tensile and compressive stress. What we are doing, we are checking the strength of the shaft in the form of their torque transmitting capacity or torque carrying capacity. If we have to check the strength of rotating shaft, what happens? The shaft is rotating at different RPM, and at the same time, it is subjected to the some amount of torque. At that time, I have to check that how much amount of torque that shaft will carry. Based on that, I will decide this particular shaft is strong or not. Now, if we take the example of beam, now beam is one of the horizontal structure, and that beam is subjected to the number of loads. So due to the number of loads applied on the beam, what happens? The bending of the beam is taking place. That means if I have to check the strength of that particular beam, I am checking their bending strength, or sometimes I am going to check their shear strength. But how it is to be checked? By using the theoretical formula, it is possible. We are having the standard formula. We are having the standard torsion formula. We are having the bending stress formula. We are having the shear stress formula. By putting the given data, I can easily calculate the theoretical calculation. But practically, if I have to check then how that particular experiments will be conducted, that we are going to check in this particular virtual lab of the mechanics of material or the strength of the material. And initially, we will focus on some of the basic testing. So if you look at from the bottom side, so here from this particular bottom side, one test they have mentioned, that is tensile test of the mild steel. If you look at here from the bottom side, the tensile test of the mild steel is there, then tensile test of the cast iron is there, then compression test of the mild steel is there, then compression test of the cast iron is there, and torsion test of the mild steel are there. So these are the basic tests which initially to be conducted on the materials, and we have to find out their practical result. And same will be carried out in the industry also. So in the industry, what happened? There are so many components are there. For example, if you take the example of the four-wheeler vehicle or the two-wheeler vehicle. So at that time, there are so many components, so many parts are there. But that components and parts, whatever it is manufactured, they are not directly used in the vehicles. So initially, the number of tests they are going to conduct on that particular material or the component, and if experimental results are very good, if experimental results are good, then and then only I can use that particular component in the further application. If immediately breaking of the component is taking place, at the time I will not use that particular component in the four-wheelers or the two-wheelers. Means initially we have to conduct the number of tests, that means experimental test we have to conduct, and if that body, that component or that part, if it will give the feasible result as per our requirement, then and then only it can be used for your further application. Then which are the common tests it will be conducted under the strength of material? So the first test is called as a tensile test. Means here I am going to change, here I am going to change the tensile strength. If I have to check the tensile and compressive, means I am going to check their tensile strength. There may be variation of material. I can conduct or I can perform the tensile test on mild steel. I can perform the tensile test on cast iron. I can perform the tensile test on the glass material. So same test, it can be conducted for the number of materials as per the requirements. That means tensile testing is there, compressive testing is there, torsion testing is there, bending test is there, shear test is there. So these are the number of tests and commonly used tests which are to be performed under the strength of material. And initially, whenever we will take one demonstration of the tensile, one demonstration of one material, so that test we will start with the tensile test, and how the stress strain diagram for the mild steel is generated, that also we are going to check in the today's experiment or in the today's session. Okay, so this is the list of the experiment in which just wait. Okay. Okay. So these are the tests which are commonly performed under the strength of material, which are that is tensile test on the mild steel, tensile test on the cast iron, then compressive test, torsion test. Okay. Also, we are going to check whatever the graph we have studied as a theoretical concept, that is stress strain curve for the ductile material or the mild steel, how that particular Now, if I will take the first test, that is tensile test on mild steel. So out of this particular number of tests, if I will click here, that is tensile test on the mild steel. So here you will get the detailed procedure, how to perform the tensile test on the mild steel, what is the basic procedure. Then some of the quizzes also they have added here. So these are the number of tabs which are correlated with the tensile test of the mild steel. If you look at to the first tab, that is here they have mentioned the theoretical part. So whatever the things related to the tensile testing is there, that all this particular theoretical part they have mentioned here, how the tensile test will be conducted, why it is to be required, then whatever the things we have discussed just now, that is how it is to be conducted on the mild steel, how the graph will be generated, so that all the basic things they have represented in this particular explanation part. And if you look at to this particular bottom side, so here this is the stress strain diagram for the ductile material, or this is the stress strain diagram for the mild steel. So this graph is not drawn, it is not drawn by some imagination. So initially they have performed the tensile testing on the mild steel, and then through experimental results, what they have got, according to that particular results, they have drawn this particular graph. And in the today's lecture, we have to check whether our graph will be generated in such a way there or not. So this is the basic theoretical part. Now important thing is that how to perform the tensile testing on the mild steel. So for that purpose, the second tab they have represented as a procedure, because whenever we have to perform any test or whenever we have to go for the experimentation, the procedure is very, very important. That means starting from the machine to stop that particular machine, whatever the number of steps are there, that we have to understood first, and accordingly we have to follow the procedure and we have to perform the test. Now in the procedure they have mentioned our objective. So what is our objective? You can see here, to study the mechanical properties of mild steel specimen under the tension load. This is our objective of the test. What is our objective? That is to study the mechanical property. Means which property I am going to check here? I am going to check the tensile strength of the mild steel under the tension load, because in the title itself they have mentioned tensile test. Therefore whatever the load we are applying on that particular specimen, that load will be considered as a tensile load. Therefore be specific, they have mentioned mechanical property of the mild steel. Which mechanical property? Tensile strength of the mild steel. Under which load? Under the tensile load or under the tension load. So this is our objective. Now if you look at to the second, now here this is the experimental setup, or many times we have seen this particular machine. This particular machine is called as a universal testing machine. In short, it is called as a UTM. Universal testing machine. In short, it is called as a UTM. So if you look at to this particular construction of this particular UTM, here one control panel is there, which is provided at the right side. Okay, and this particular big structure, which is to the left side, this is the big structure, represents the actual UTM. Okay, so here the two wheels they have mentioned. One wheel is mentioned at the top side and another rotating wheel, circular wheel, it is mentioned at the bottom side. Why these wheels are rotated? In order to move this particular jaw in the upward direction and the downward direction, because your length of the specimen is varying continuously. If length of specimen is varying continuously, at that time, as per its length, we have to adjust this particular jaws. Maybe you have to take in upward direction or we have to take in downward direction, and accordingly we have to fix that particular specimen in this particular two jaws. Okay, then this is the control panel. Okay, through this particular control panel we can start the machine, you can stop the machine, how much amount of load is applied on that particular specimen, it is also recorded by using this particular display device. Also here one indicator, dial indicator is also provided in order to measure some of the dimensions whenever the machine is started or whenever it is in working condition. So this is the basic construction and working of this particular machine, which is called as a UTM, or it is also called as a universal testing machine. Okay, so this is the basic construction. We will see how this particular wheels are movable, how the component is to be fitted, how the machine is to be started, how machine will be stopped. That all the detail we will see practically also in the form of simulation manner. Now the second step. Again here they have represented the apparatus used for the testing purpose. Again, here UTM is there, control panel is there, this dial indicator is there. Also, we are using the vernier caliper because mostly whatever the specimens we are testing here, that specimens are circular in cross section. And if we have to measure the diameter of that particular specimen, which apparatus or which instrument we are using, that instrument is called as a vernier caliper. So that vernier caliper is mostly used to measure the diameter, because the diameter or dimensions of the specimen, it is very, very important. Before carry out the test on that particular specimen, their diameter and their length, it is very important to measure. And in order to measure all that particular dimension, this vernier caliper will be used. Okay, so these are the different types of the apparatus which are used for the testing purpose. Now, what is the first step? Before we have to keep, this is the first step. What they have represented here at the right side, your specimen is there. That specimen is circular in cross section. At the left side, they have represented one instrument which is called as a vernier caliper. That means your first step is that before we have to attach or before we have to put this particular specimen on the machine, what is the first step? We have to measure its diameter. We have to measure its diameter. So this is the first step, because that diameter is one of the given parameter. If you look at to the statement, in our statements also, one rod is there. That rod is having diameter 50 mm, length 500 mm. These are the given data they have mentioned in the statement of the problem. But here, such type of statement is not there in the testing. Initially, we have to measure all the dimensions by using the measuring instrument, because all that particular dimensions are important for the further calculation. So what is the first step? To measure the initial diameter of the rod in the two perpendicular directions. And that means in one direction that diameter will be measured, in another direction also diameter will be measured. In the both direction, if it will same, then you have to take the average. Initially I have measured in one direction, diameter is 50 mm. Again I have measured in the another direction, again diameter is 50 mm. So 50 plus 50 divided by 2, you will get the average diameter as a 20 mm. So this is the first step to measure the diameter. Then second, length. We have to measure the length. From which point to which point we have to measure the length, you can see here. From which point to which point. So then some additional portion is provided at the left side and at the right side. If you look at in this particular figure, this is the additional portion is provided at the left side and the right side. What is the use of this particular additional portion? Because whenever we have to hold or we have to attach the specimen in the machine, so this much amount of portion will be used in order to attach this particular specimen in the jaws, because some amount of portion is required to hold this particular specimen in the machine jaws. Therefore, whenever we are measuring the length from this point to this point, we have to measure the length, or this is called as a working length. So remaining part, it will not be considered as a measurement part, because it will be used for just for the holding purpose. So initially by using that particular scale, we have to measure the length. This is your second step. Then third, now punch marks are made at a distance of 2.5 mm. So what they have written? Punch mark. So whatever your specimen is there, initially we have measured diameter, we have measured its length. Now we have to apply the punch. So simply we have to take this particular punch, and by using the hammer, we have to apply their punch. And at what distance, or what is the distance between punch number 1 and 2, 2 to 3, 3 to 4? Here they have written the formula. What is that? 2.5 into diameter. So 2.5, it is the multiplying factor. If the diameter of your rod is 50 mm, so 2.5 into 50, whatever the answer you will get, that answer represents the distance between the two punches. And why these particular punches are important? Because at the end, what happens, whenever we are applying the load on this particular specimen, there is an increase in length. Why increase in length? Because we are applying the tensile load. Then how much amount of length will get increased? That will be checked by measuring the distance between the two punches. So initially, for example, the distance between the two punches is 30 centimeter. Okay, and after load is applied, after load is applied, and if I have to measure the distance between the two punches, at that time the distance between two punches will be increased. Why? Because due to the tensile load, there is a increase in length of the specimen, and in order to check that increase in length, we have to measure the distance between the two punches. Therefore, in the tensile testing, the marking of this particular punch, it is also very, very important. And this is your third step. And what is the distance between the two punches? 2.5 into diameter. This is the third step.
Hello,
Then
sir.
fourth step.
हॅलो
Yes.
सर, ते पंच केल्यावर त्या बारच्या स्ट्रेंथवर काय फरक पडणार नाही का?
It just for indication purpose. It is very, very small punch. That diameter is very negligible. It is near about 1 to 2 mm only. Just for marking purpose. Just for marking purpose, we have to apply the load, and just it is very small in dimension. It will not be affects on the strength.
ओके सर.
Okay.
Okay,
It is not affects on the strength. It is just marking. We are not making a big hole of 5 mm, 10 mm. It is not like that. Just that marking is visible to us. Based on that only, we have to apply that particular punch. Just it is visible to our eyes. That much is sufficient.
ओके सर.
Okay. Now the fourth step. If you look at the fourth step, what they have done in the bottom side, one rotating wheel is there. We have to rotate that particular wheel in such a way that your specimen should be attached in this particular two jaws. So one wheel is provided at the top side, but it is totally fixed. And whatever the wheel is provided at the bottom side, it will be rotated in clockwise direction, or it will be rotated in anti-clockwise direction. As per the requirement, as per the length of the specimen, we have to rotate that particular wheel either in clockwise direction or either in anti-clockwise direction, and we have to fit your specimen in the two jaws. Once the specimen is fitted, immediately whatever the dial indicators are provided, you can see in the figure, the two dial indicators are there. One dial indicator is provided at the left side, another dial indicator provided at the right side. That means simultaneously we can measure the two dimensions. Simultaneously we can measure the two dimensions. Once your specimen is hold on the machine, immediately you have to attach the dial gauge indicators also for your further reading purpose. So this is the step number 4. Now step number 5. Whatever the dial gauge indicators we are providing, that dial gauge indicators are called as a extensometer. That dial gauge indicators are called as a extensometer. And whenever we are providing that particular extensometer with the specimen, first requirement is that we have to adjust their reading equal to 0. Initially, if that dial gauge indicator is showing the reading of 10, 20, 50, 60, at that time we are unable to give the proper calculation. So once the specimen is fitted in the machine, and if the dial gauge indicators are attached to the specimen, immediately we have to make their reading equal to 0. So this is the requirement. We have to make the reading of extensometer or the reading of that particular dial gauge indicator equal to 0. Therefore, we can start your actual reading from the 0 point. So this is the step number 5. It is very, very important. Sometimes we are making the mistake. We can keep the previous reading as it is, and at the end, we are unable to take the correct calculation or the correct reading. Therefore, it is very important to adjust it equal to 0. So this is the step number 5. And next, if all these particular parts are fitted, extensometers are fitted, simply you have to start the machine. On the control panel, the two separate switches are provided. One is for the starting purpose, another is for the stop purpose. And always, whatever the green, if you look at here, the green color is there for the starting the machine, and the red color is there for to stop the machine. So if we'll start that particular machine, we have to press that particular green color button. Machine is started. Once the machine is started, means what happened here, that particular specimen is under the tension. Automatically the tensile load will be applied on that particular specimen, and their extension will be started. And once the load is increases, here at the right side we can see one table is there. In that table, if you look at to the columns, first column is load, second column is reading of the extensometer, point A, point B. Point A means reading of extensometer number 1, point B means reading of extensometer number 2, and then you have to take the average, and that average value we have to consider for your further calculation. And this particular table automatically it will be generated on your computer, because this total system, this total machine is automatically operated. Automatically it will create this particular table, and automatically you will get the graph. Now if the machine will be started, the specimen is under the tension, and due to that particular tensile, then extension will be taking place, and one point you will get in such a way that the breaking of the component will be taking place. You can see here. If you look at here, at the center point here, there is a nick formation. You know what is meant by the nick formation. Due to the nick formation, the cross-sectional area is goes on decreasing, and at one point, the specimen will get break into the two portions. Once it will get break, you have to stop your machine. Once it will get break, you have to stop your machine. And once the machine will get stopped, you will get this particular table, that is load their extensometer readings, and by taking the reference of that, finally you will get this particular graph. Now if you compare this particular graph with our stress strain diagram for the ductile material, it is similar to that. What is indicate? The stress is directly proportional to the strain. That one inclined line is there, that is proportional limit. Then in the after the proportional limit, at some distance, one elastic limit point is there, then upper yield point is there, then at the bottom side lower yield point is there, then there is a ultimate stress point is there, and the fracture is taking place, which is called as a breaking point. This graph you will get through the experimental testing. This graph you will get through the experimental testing. It is not drawn by the imagination. Whatever the reading you will get here, what is the reading you will get here in this particular table, by that particular reading, this graph will be generated. And by taking the reference of this particular graph, it will be added in your syllabus as a stress strain diagram for the ductile material and the stress strain diagram for the brittle material. So like that, you have to perform the test. So this is the graph of load versus scale readings. And one more graph they have represented, load versus extensometer reading. That means if load is increases, the dimension, change in dimension is also goes on increasing. If load is increases, change in length or increasing length is also going to increase. And through this particular graph, we can say that due to the increase in load, the extension is also goes on increasing. And by observing this particular graph, we can say that this particular graph is applicable for the ductile material, because it will vary from various points from proportional limit, upper yield point, lower yield point, ultimate stress, and the breaking point. So this is the actual process we have to follow. And at the end, again, by taking the vernier caliper, again we have to measure the diameter where the breaking is taking place. So we have to compare your initial diameter and diameter after the breaking, and we have to check that how much amount of diameter it will get reduced, and also we have to check how much amount of extension will be taking place. Now you can see here why that punch marking is very important. Why that particular punch marking is very important, because due to this particular extension, if I will measure the distance between this particular two punches, and if the distance is vary, then I can say that the extension of the rod is taking place, or maybe compression of the rod is taking place, or no. So this is the actual procedure we have to follow, and then we have to find out your final results. What is the yield stress? What is the tensile strain? What is the modulus of elasticity? How much percentage elongation is taking place? How much percentage area of reduced? That we have to check at the end. By the theoretical calculation also we can calculate, and by the experimental calculation also we can calculate. So this is the procedure I have explained. Now we will perform actual simulation. You can see here. Now we will perform actual simulation. So once again, whatever the points we have discussed here, same points we will perform the experimentation. How the experimentation will be performed. Now this is the setup in front of you. Control panel is there. Then here one person is also there who is having this particular experience, or who is having knowledge about operating this particular machine. Now I will take the test. Now here you can see one arrow is blinking. If you look at here, one arrow is blinking, means what it indicates. Now we have to measure the diameter of the rod. So I will click here. See, animation is there. We have to measure the diameter. So initial diameter in one direction, 11.50 mm. This is the diameter in one direction. Again, that arrow is blinking here. Again, I will click. Again, it will measure the diameter. I will get the another diameter, that is diameter in another direction. How much? 11.50. That means in one direction or in X direction, diameter is 11.50. In Y direction, diameter is 11.50. If I will take the average, my final diameter is equal to 11.5 mm. So this is the step number 1, whatever we have discussed in the procedure. Now next, again here arrow is blinking. What it indicates? We have to measure the working length. So if I will click here, it will measure the length from this point to this point. How much amount of length is there? 192 mm. So you can see here. Length is mentioned 192 mm. So this is the second step we have performed. Then next, now here to apply the punch. So here, third step, we have to apply the punch or we have to mark the punch, means here one arrow is blinking. So the first punch will be applied at the left side. So first punch is applied. Okay. Then if I have to apply the second punch, then I have to calculate the distance. So we are having the formula. Distance, that is 2.5 into diameter. So 2.5 as it is. Diameter, how much diameter is there? 11.5, and you will get the answer 28.75. And that 28.75 represents the distance between the two punch marking. So the first punch is applied, then second punch is applied, then third punch is applied, then fourth punch is applied, and fifth punch is applied. It depends upon the length. If length is more, number of punches we can apply. If the length is as per our requirement, what are the number of punches are required, that we have applied here. So like that, we have applied the punch. The punch will be applied in such a way that that marking should be visible to you. You can see here that marking is visible to you. Now punch is applied. Now next, what is your requirement? We have to rotate one wheel, due to which this particular jaw is rotating downward direction, or it is moving in the downward direction. So you can see here one arrow is blinking. If I will click on that particular wheel, it will be moving in the downward direction. Okay. Now the specimen is there. We have to fit this particular specimen in the two. Specimen is fitted. Again, we have to rotate that particular wheel. You can see. Now the specimen is perfectly holded. The specimen is perfectly holded in the two jaws. Specimen is perfectly holded on the two jaws, and once it is holded, immediately we can attach the two extensometer. One is at the left side, another is at the right side. Now, next, we have to make it equal to 0. Whatever the extensometer is attached to this particular specimen, we have to make it is equal to 0. Therefore, in order to make it equal to 0, here one arrow is blinking. If I will click there, the pointer come to 0 point. You can see here. Again, on the second, initially the pointer is somewhat inclination. If I will click here, pointer will come to the 0, and least count of the extensometer is 0.01 mm. The least count of the extensometer is 0.01 mm. Now, specimen is on the machine. All the dial gauges are set at the 0 point. Now, again, the arrow is blinking. What it indicates? We have to start the machine. Once I will start the machine, what happen? The load on the machine will get started. That is tensile load. At the right side, you will get one table, and in that particular table, you will get the reading. Now you can see here, I will start the machine. See, machine is started. Here you will get the number of readings. Load, reading of extensometer A, reading of extensometer B. Here you can see nick formation, how nick formation will be taking place here. Now it is braked. Specimen is braked. Once the specimen is braked, need not require to continue the machine. You have to stop the machine. Machine is stop, and here you will get the number of readings. How much amount of load is applied? It is started from 2 kilonewton and it is end at the 34 kilonewton. That means 34 kilonewton is the maximum load that material can sustain. Now, if you go, this is the graph which is generated through this particular table. Whatever the graph, whatever the readings we have seen in the previous procedure, by taking the reference of that, this is the graph which is to be generated. So in that particular graph, proportional limit is there, upper yield point is there, lower yield point is there. Then this is the ultimate stress point is there, and this is the breaking point is there. So this is the graph of load versus scale reading. This is the graph of load versus scale reading, and this particular graph is called as a stress strain diagram for the ductile material. And also we can find some of the other information also. Where is the maximum stress point, where is the breaking point, where is the proportional limit, where is the upper yield point, where is the lower yield point. All that particular important points we can see through this particular graph, and then this particular graph is added in your theoretical syllabus. Okay, then next, this is also one more graph, that is load versus extensometer reading. That means if load is increases, the extension is also going to increases continuously, and it can be visible through this particular inclined graph. The graph is continuously inclined. That means if load is increases, the reading of the extensometer is also increases. Why? Because whatever the load we have applied, that load will be considered as a tensile load. That load will be considered as a tensile load. Therefore, there is increase in length only. Okay, so this is related to the. And now here we have to measure the diameter. Simply, if I will click here, the part will get joined, and I have to measure the diameter. What is the final diameter? You can see 7.79. Before application of load, what is the diameter? 11.5 mm. And once the component will get break into the two portions, what is that particular final diameter? 7.79. That means 3 amount of mm diameter it will get decreases. Increase in length, we have to measure. Simply I will click here. How much amount of length between the two punches? 77.31. 77.31. So what is the distance between two punches? 28 mm. So 28 plus 28, 56. That means distance between the two punches, or from this point to this point, this is 20 mm, 28 mm, this is 28 mm. That means 28 plus 28, 56. But now how much it is showing? 77.31. That means there is a increase in length. And how that particular distance will be measured? For that purpose, this punches or punch mark is provided on the specimen. If the punch mark is not provided, at that time we are unable to give the correct dimension. How much amount of what is the final length of that particular specimen. So in order to check that particular dimensions, change in dimensions, this particular punch markings are very, very important. And now this is the some calculation part. Now here, what are the problems we are solving in our class? Simply we have to do the calculation. For example, here I am applying my yield stress is equal to 150. Okay. Then my tensile strength is equal to 230. Modulus of elasticity is 200. Percentage elongation is 40%. Percentage area reduction is 50%. And if I will check, so these are my entered values: 150, 230, 200, 40, 50. But what is the actual values we have obtained from the graph or obtained from the testing? What is the actual value? 356.39. Tensile strength 549.03. Modulus of elasticity 209. Percentage elongation 30.5. Percentage reduction in area 54%. And at the end you will get the percentage error. That means whatever the theoretical calculation we have carried out and whatever the experimentation we have carried out, how much percentage error is there, that we have to check. If you if your percentage error is in between 15 to 25 mm, that much error will be accepted, because there are so many errors are there. That is manual error is there, then experimental error is there, human error is there, instrumental error is there. So all that particular number of errors, it will be considered under the 15 to 20%. But if your error is very maximum, 50%, 60%, that means we can say that we have made somewhat mistake either in theoretical calculation or either in experimental calculation. So for that purpose, the testing is very, very important. In your regular syllabus, such types of the testing, it is not in your syllabus, but in actual practice, such type of testings, it will be conducted on the specimens, components, parts, and then only it can be used for your further applications. So this is related to the tensile testing of the mild steel. So detailed procedure we have discussed from the starting of the machine to stop that particular machine. What is the basic procedure we have to follow, that we have discussed through this particular first practical or the first session or first lecture based on the tensile testing of the mild steel. Okay, so this is related to that. So have you understood this particular practical, or have you understood this particular test, how the tensile testing will be conducted on the mild steel? If you are having any problem, you can ask me. Okay, no. Now this is the tensile test on the mild steel. Okay, now if I will change the material, suppose if I will take the another test, tensile test on the cast iron, same procedure we have to follow. Same procedure, whatever the procedure we have followed for the mild steel, same procedure we have to follow for the cast iron. But what results you will get for the cast iron, that we have to check, because the cast iron is very strong material as compared to the mild steel. What exactly happens once the testing will be performed, that we have to check, and we have to make the comparative study. Same testing I am performing on the mild steel, same testing I am performing on the cast iron. But as the cast iron is very strong as compared to the mild steel, what results you will get, that we have to check. So whatever the procedure is there, same procedure we have to follow, that is measuring the diameter, then measuring the length, okay, then mark the punch, then attach the specimen here, hold the dial gauge indicator, start the machine, stop the machine, and you will get the different types of the reading. Same procedure we have to follow, but what is the final readings, that we have to check. So once again I will start the simulation. So now the machine is ready, operator is ready. Now next step, measure the diameter in one direction, in X direction what is the diameter, 21.90. In Y direction again I have measured the diameter 21.90. My average diameter is 21.9 mm. Their cross-sectional area I have calculated pi by 4d square, 376.68 mm square. That means first step is over, that is measure the diameter in two perpendicular directions. Second, measure the length. Only working length I have to measure. How much length is there here? They have mentioned 187. See, 187 mm. This is the length of the cast iron specimen. Here it is not mild steel, it is cast iron. Next, mark the punch. Now here diameter is different, therefore 2.5 into 21.9. The distance between the two punch marks is 54.75 mm. So the first mark is there, then second, then third, fourth. Okay, the 4 punches are there as per the length. Now rotate the wheel, bottom wheel we have to rotate because we have to adjust the specimen there. Okay, so I will take this particular specimen here and I will drag here. Okay, again rotate the wheel, so it should be properly fitted in the two jaws. Immediately we can attach the dial gauge indicator, or here it is also called as extensometer. Sometimes we can attach one extensometer, we can attach the two extensometers as per your requirement or as per accuracy required. Okay, now make that particular dial indicator is equal to 0. So if I will click here, it will show the 0 reading. Same procedure, start the machine. Machine is started, load is applied. Which load? Again tensile load we are applying. Okay, tensile load we are applying. Load versus dial gauge indicator readings we are seeing here. If you see here, the nick formation is not visible properly because now you can see, now machine is stopped. Directly the braking will be taking place at the top side. You can see here. Here the braking is taking place in the specimen. Nick formation is somewhat visible, somewhat it is not visible. Now we have to check what is the stress strain curve. See what difference we have understood for this particular stress strain curve, or if I will compare this graph with mild steel. In the mild steel, you will get the number of points, that is proportional limit, then elastic point, upper yield point, lower yield point, ultimate stress point, and then you will get the breaking point. But on the mild steel, same process. I got the graph in this particular way, that is load versus this particular scale readings. Why this particular graph you will get this through this particular or in this particular manner? Because the cast iron is very strong, or its strength is very strong as compared to the mild steel, and due to that, that much variations it is not observed in the cast iron. That means whatever the proportional limit is there, whatever the elastic limit is there, then upper yield point, lower yield point, ultimate stress point, that particular variations it will not be observed. Once the load is increases, their continuous elongation is also taking place, and at the end there is a only breaking. Why the graph will get changed? Because the strength of the cast iron is very high, or it is maximum as compared to the mild steel. So this is the first graph. And if I have to measure the diameter, you can see here, this is the breaking component. If I will join here, and if I will measure the diameter, see how much diameter is there. They have given one note. Change in diameter is negligible. Change in diameter is negligible. That means on the cast iron, that much variations are not taking place, or that much readings are not going to change. Therefore, they have given the statement like that. Change in diameter is negligible. That means very less amount of decreasing diameter will be taking place in the cast iron. Why? Because its strength is high or maximum as compared to the mild steel. So this is the diameter measurement. If I will check the length, again here they have written the statement, the change in length is negligible. That means if I will measure the distance between this particular two punches, whatever the change in dimensions you will get, it is very, very negligible. Means I can say that the elongation of the cast iron is taking place. It is taking place, no problem, but it is very, very less as compared to the mild steel. Why it is less? Because cast iron is very strong as compared to the mild steel. Cast iron is very strong as compared to the mild steel. That's why only you will get the different results for the mild steel, because it is mostly considered as an elastic material. Mild steel will be considered as an elastic material, or it will be considered as a ductile material. Therefore, maximum variations you will get in the mild steel in the form of change in diameter and the change in length. But the cast iron is very strong, so that much variations are not observed, so it becomes negligible. Again here, if I will enter my rough value, 150, 200, 50, 40, modulus of elasticity 200, and if I will check, again here you will get the actual readings. So these are my entered values. Third column represents entered value. But what are the actual values? You can see what are the actual readings that they have represented here. 156, 190, 199, 17, 10, 20, and here at the last column you will get the percentage error. And through this particular percentage error, we have to check that whether our experimentation or theoretical calculation is correct or not. If maximum percentage error you have observed from this particular two readings, then we can say that either we have made the mistakes either in theoretical calculation or either in your experimental calculation or experimental testing. Sometimes the maximum errors sometimes we are making the wrong calculation by using the calculator. Some students got the different answers, some students got the different answer. Why? Because we have made the mistakes in the calculation. Sometimes in the testing part, in actual experimentation, some students are following the another procedure, some are following the another procedure. So these are also chances due to which you will get the different readings. Therefore, at the end, we have to check the percentage error, and that percentage error should be very, very less. If it is very, very less, then we can say that your theoretical calculation is also correct and your experimental calculation is also correct. So like that, we have to perform the tensile testing on the different types of the materials. And here we are checking the strength. We are checking the mechanical strength of the mild steel. We are checking the mechanical strength of the cast iron. Therefore, that particular testing is called as a tensile testing of the mild steel and the tensile testing of the cast iron. So this is related to the first two experiments, which are very basic and commonly that particular experiments are performed in the industry in order to check the tensile strength of that particular material. Without this common testing, material will not be used in any type of application. Okay, so this is related to the tensile testing. Understood? Anybody is having any problem? Let me know. Have understood both the testing and what difference is observed in the mild steel and the cast iron? Yes, have understood all the things? What is the procedure we have to follow? How to operate the machines? Which readings we have to take? What care should be taken during the experimentation? Okay, so with this, today we will stop here. Now I request you all, just type your division and roll number in the chat box for the attendance purpose. Type your attendance in the chat box and then you can leave the meeting.